the reason why I write tests is this, because I want to deliver software faster. Mark the words, deliver, not write. Deliver to real users, to paying customers. And, well, to be more precise, not just any software, valuable software. Nobody wants to write software that nobody wants. And I'll have to be even more precise here. We need to write software faster, deliver software faster, sustainably. We need to be able to deliver faster and keep going at the same speed or faster. So this is the main reason why we need to write tests. And again, there's two main reasons I see why tests help us to deliver valuable software faster. One is the developer perspective. The developer says, I use the test to help me write new code, to help me develop new behaviors in my system. So they help me design my code. And there's the tester perspective, that is, the tests keep making sure that my code does what it's supposed to do. Doesn't contain any new mistakes. So if a test does not meet one of these two reasons for existing, it's not a good test, it's waste, something that it has no value writing and maintaining. So I delete it. And I will continue with an example. So I don't want to pick up on the guy who wrote this presentation, who certainly is much more knowledgeable about Android than I am. That's Diego Torres Milano, who wrote a book on testing, which is fairly good. I think this book is more on the tester perspective than on the developer's perspective. So I will present to you this test as an example of a test that, well, what does this test do? It checks that some widget in a view has the expected gravity. So the combination of a right and center vertical. Okay, so I write this test and it's broken, doesn't pass. So I do something in my IDE to configure the right gravity for this widget. And then, lo, the test passes. And what do I get? Yeah, I gave myself permission to do the thing that I knew that I had to do. What's the value in this? So there's a kind of testing that to me is a bureaucratic testing. I know I want to do something, so I write a test that allows me to do that. Then I do it, and then I feel good because I wrote a test. But not much value has been delivered, in my opinion. So, what is a good way of testing, in my opinion? I think of a behavior that my system should have, but doesn't. And I'm not yet sure how to implement this behavior. So, I start by writing a test that proves that the behavior exists. And then I can experiment in more than one way to get that behavior to work. And this is valuable because it's a way to go forward, to learn new things about how my software can be written. This teaches me something because I start with a behavior that I don't yet know how to implement. And this basically is TDD. I think that you all have heard about TDD, so I don't have to spend too much time defining TDD. So I'll briefly show this picture. So TDD is a process where you write a failing test quickly, then you make it pass quickly, and then you refactor as much as needed. And essentially, this cycle should be fast. You should be doing these many times per hour. Okay, so what's the problem with Android? There's more than one problem when we try to TDD with Android. And the one I would like to focus on is speed. Because if I write a test that works with the Android framework and APIs, etc., it needs to work on the device. And so I have to compile the whole project, deliver it to the device, and then run the test on the device. And this takes more time than I would like to. So there's ways to avoid this delay, the time that we waste delivering and executing the code on the device every time. And these ways are improving, but in my humble opinion, they are not there yet. So this is a sample of thousands of blog posts that you can find on how to configure this and that library with the Gradle and Android Studio. Mainly Roboelectric, but not picking on Roboelectric, which is certainly an amazing piece of engineering, but making it work reliably and keeping it working is a lot of work. And what kind of work is this? I mean, there's any activity that you do is either value adding or waste. You can easily tell the two by performing this experiment. Suppose you go to a customer and say, "Hey customer, I spent the whole week fixing the build. Are you happy?" Other experiment, "I spent the whole week writing valuable software for you." Which one feels better? So, fixing the build is waste. We'd like to avoid doing that as much as possible. So the main thing I want to talk to you about is how some old-fashioned programming skills can avoid the need to install fancy libraries that will allow you to bypass some of the problems that Android testing has. And as a result, these techniques that I'm going to talk about will be usable in Android with Java, but also in many exotic programming environments that you will find in your programming work. So, the first idea is pretty much old. This model view separation. Have you heard of this? Okay. So, I guess this will be a bit of a letdown. Perhaps you expected me to talk about some advanced, fancy, difficult stuff. It's not. The most difficult thing for a programmer to progress, in my opinion, is to give up the love of complexity. So what I'm going to explain today are very extremely simple things. So model view separation is basically this. We partition our code so that there's no logic in the view. And by the view, I'm not talking about what Android calls a view. I'm talking about the UI in general. So the strategy is take every logic, every if statement that you have and move it to a place that does not depend on the Android framework. So you will end up in a situation like this. In your Android Studio, you probably have two modules. One is the app module that Android Studio built for you, which of course depends on Android libraries. And then you build a new one, a new module that's pure Java and does not depend on Android. So this is where you will run your unit test and where you will do most of your TDD work. And here on the app module is where you will be running your end-to-end acceptance tests that will make sure that this passage works. And the point is, most of the work should be here, because here it's easier to work, it's easier to test. Low maintenance stuff, just plain Java code. Okay? And so the variation of TDD that I will be talking about is acceptance TDD. You start with a failing acceptance test, then you keep it broken for a while because you have to do a lot of work to make it pass. So you work in TDD for a while, and when you're ready, you go back to the failing acceptance test and it passes, and then you can write another. But the point is that you will have a few acceptance tests and many unit tests. Examples. So this is level 1. You work with an application that uses form widgets. So this is very easy. Your acceptance test can use the standard instrumentation APIs. and Espresso and whatever fancy libraries you want. But here is where you can go crazy and use the native Android stuff. And one thing I like to do is to wrap the whatever API we are using to test with custom methods that speak the language of the problem that we have to solve. So this method, given the user selected conversion inches to centimeters, you see, the idea of this application is that I write the name of a unit here, another name of another unit here, a number, and then the result of the conversion from one unit to another goes here. So these methods are implemented very easily with going into the Android view and manipulating the widgets. But you can't see it from here. So the technology that we are using is not apparent from the text of the acceptance tests. So this gives us freedom to upgrade the way we implement the tests while keeping the logic of what we want to test separate. Okay, this is pretty easy, right? Okay, so then the simplest thing that you can do at this point is to start hacking your new project until the point where you can say, I get all the inputs and here is where I put the output. This string I'm creating here, hello, and the concatenation of the inputs proves that my plumbing to get the inputs and the outputs from Android works. At this point, the simplest thing you can do is to imagine you have a new object that performs the logic. Like new unit doctor has the name of the application, dot convert input from unit to unit, and return something that is put here. Now you can start TDDing this object. Simple as that. Okay, so this is the kind of unit test that you could start doing. This is interesting because it also deals with conversion. I don't want to leave the conversion part on the logic on the Android side. I also want to control how the conversion from numbers to strings and vice versa works. But you have a choice here. So, okay, this is very basic stuff. But I hear you saying that it does not scale for complex applications. So suppose that whenever the user does something, you also have to change many things on the UI, and these things are not always the same things. So I touch here and maybe 3 things somewhere else change, but if I change something else, then other things change. And this breaks the simple approach that we've seen before. So, to address this, I will present another well-known technique, which is presenter first. So, assume that your architecture is done like this. You have the logic object and the view object. And again, I'm talking about view in the object-oriented meaning, not in the Android meaning. So we have a view that you can get input from, and we can manipulate to make things happen on the screen. And we have a logic object that depends on this view, but only through an interface. So we create an interface that shields the logic object from the details of how the view object is implemented in the Android world. And we can develop the logic without or before we implement the logic object, the view object in Android. So I don't know if you are familiar with the JMock syntax. I think JMock is the best mocking library there is for doing TDD. I know Mockito is fairly popular, but I view Mockito as something that's more useful to rescue legacy application. While JMock is more useful for doing TDD from scratch. So what this thing does is we create a mock view from some interface unit doctor view.class that does not exist yet. Then we create a new unit doctor object that takes as a dependency the view. And then this block says that we expect that when the view dot input number is called, it will return this number. And when from unit is called, it will return the string, etc., etc. And we expect that at some point, show result will be called with this number. So this is the block of all the expectations that we are giving to JMock. Then we call unit.convert, and this will should make these expectations pass or fail. So the fun part of this is that when we start writing these, the interface doesn't even exist yet. So we invent the interface by writing the test. And if you answer this question, what are mocks good for? And your answer is something like mocking Android APIs, you're wrong. The real value that you can get from mocks is that they help you design your interfaces. In fact, you should never mock APIs that you have not invented. Mocks are meant to design interfaces. I can't design Android's interfaces because they're not under my control, so there's no point in me mocking Android interfaces. I will mock my own interfaces, like this one. So this is the view that emerges from writing the test. I need this method, and this method, and this method, and this method. Where do I implement this interface? This might be implemented in the activity of the Android app, or maybe in a view, in a real Android view, or in another object that I will invent in the Android side of things. Doesn't matter here. And going forward, you write all the other tests and you discover new things you have to add to your interface. Like when the units are unknown, what happens? I will not write a number. I will ask the view to somehow show that these units are not supported. I don't know how. Maybe toast message, whatever. I don't need to test it here. And add this method to the interface. Okay, are you with me so far?
Yes.
Good. So, I've been cheating so far. So, widgets-based applications are very easy to implement. So, what happens when you really have to deal with an Android API that's not just text fields? What do you do then? So there's this example that I stole from a book by Carlo Pescio. It's an application where you can draw with your fingers, multi-touch. The colors are chosen randomly and they decay eventually. So you make a drawing and little by little the line disappears. And so implementing this will require us to deal into the view API, how to draw the canvas, the touch events, and all these sorts of things. How do we deal with them? No! we don't mock them directly, but we will write adapters that will shield the pure logic, pure Java side from the Android side. So, what's the acceptance test here? Here it's more difficult because Monkey Runner does not support multi-touch. At least it didn't when... Acceptance test. Second test, 2 fingers. Third test, you want to make sure that multi-touch is implemented correctly. So you drag one finger and the other makes a dashed line. And if this works, you're pretty confident that your application works. So there's no technology that I was aware of making possible to implement all these 3 acceptance tests. So what we did was to implement this test with Monkey Runner, and the other 2 are manual takes you less than a minute. So whenever you want to deliver, you have to perform this test by hand. And again, the way to start when you're working with an unfamiliar API is start with a spike. So you start with an experiment, and the first thing I wanted to do is to prove that I can write a line on the screen. And it turned out it's fairly easy. So Android is pretty fun to work with because it's easy. The API is not surprising. So then the second step was to follow the finger. So we implemented this second. I say we because I've been working with my friend Carlo Bellettini doing this. And what emerged from this experiment is that there's a method on the view on touch event that will receive motion events. So what you're supposed to do in this case is to receive these events and grab the coordinates and then save them in some data structure. Here we have a list of points. Then when on draw is called, you have to take this list of points and draw them, draw lines, a sequence of lines between these points. So this is the basic architecture behind this application. The point is that this data structure is going to be more complicated than this if you want to implement multi-touch. Otherwise, it will be almost finished already. So what do we do? At the beginning, we are in this situation. We need to write an application that will completely depend on these two Android APIs, the motion event and the canvas. This is the input and this is the output. So we Can you hear me again? Okay. So what do? We implement adapters. These objects are adapters. They implement a simpler interface that Fairy Fingers, the name of the application, uses. So Fairy Fingers will be developed in terms of these interfaces, and we'll have to implement adapters that implement these interfaces using Android APIs. So we separated concerns. We have the logic of the application here and how in practice we draw and sense things on the Android. And this makes the two sides simpler, rather than what if we implemented everything in terms of Android APIs, it would be more complex because concerns would be mixed. So simplicity often means separating things. And so this will again be the structure of the project, two modules. And this is the example, the simpler one of the two is the canvas. So suppose that our own simpler canvas is called core canvas, for lack of a better name. All we need to do here is to draw a line with, from this point to this point. So when the onDraw is called, we need to do something like, for every line that the core object contains, we call draw on this line object, which is also an object that we have implemented in pure Java. Passing it a new core canvas implementation that is an anonymous function that uses the canvas object to implement drawLine. So it's pretty simple, difficult to get wrong, and anyway, we will be testing it with acceptance tests. It is a bit more complicated to interpret the multi-touch events, because the data structure is way more complicated. So this is the interface that we implemented. The core motion event, which is a simplification of the motion events, has an action, which is a constant action. Down means that a sequence of things happens, is starting. Up means that a sequence of things is finished. And move means that some finger is moved. Action pointer down means that another finger has been added to the set of fingers that are currently on the screen. And pointer up means that one finger has been lifted. So we had needed some time to study the APIs and experiment with the device and trace in a log what happens when we drag the fingers in various ways. So we dumped the information on the log and examined the logs to have a better understanding of what the re-implementation would have needed to be. So again, when we receive an untouched event, we create a new core motion event, which is again an anonymous class that is implemented in terms of the original Android motion event. And here you see that it's a very simple transformation, so that the unit tests are simple to write. So I say that, for instance, when on touch is received with an event down with these coordinates, I assert that now I have one line, and this line contains this point. It starts at the 10, 0, 100, 0. So this is another trick that I've been using. I could assert things on the content of the line object, but it's simpler to assert on its toString, because the toString is something that I use for mainly debugging purposes. So the line object that is returned here has a toString that dumps the contents of the line. So when we have more events like here, down, move and move, now we know that the first line contains this sequence of points, etc. So this is basically it. Increasing your programming skills will get you much farther than researching new libraries and seeking salvation in new libraries. So seek within yourself and your design skills what you need to improve. And think of every activity that you do, if it's value-adding or not. Some wasteful activities are necessary, some are not, but we try to keep the waste to a minimum. And remember that the goal is to deliver valuable software faster and sustainably.